Myself Dinesh, working as Assistant Professor, Department of Physics. Dear students, in this video lecture, I am going to explain the Newton rings. Here in this topic, we learned about the concept of Newton rings, diameter or radius of the Newton rings, and determination of wavelength of monochromatic light, determination of refractive index of liquid. Let us see what are Newton rings. Here, when a plano-convex lens of large radius of curvature is placed on perfectly plain glass plate, a thin film of variable thickness is formed between the surfaces. If the lens is illuminated by a monochromatic light, a series of alternate bright and dark rings are formed with the central dark spot. The rings get closer and closer as we move away from the center. These rings are known as Newton rings. Let's see the theory of Newton rings. Here this is experimental setup. The figure 1 shows the complete experimental setup. Here it consisting of plain glass plate and plano-convex lens and traveling microscope and the monochromatic source. This one is reflected system. We can analyze the diameter of bright and dark rings using this diagram. This illustrates about the Newton rings. Here the center spot is always dark. The rings, when we move away from the center spot, the rings goes on very thin and closer to each other. This is about the radius of curvature of given plano-convex lens. Let us see the theory of Newton rings by using these diagrams. Students, in the reflected system, consider a plano-convex lens placed on a plain glass plate G. In this diagram here, thin air film is enclosed between the two surfaces here. When a ray of light is incident on the lens like this, a part of the light is reflected from the point A at the lower part of the lens, and the remaining part is reflected from the point B at the upper surface of the glass plate shown here. These two reflected rays, that means ray 1 and ray 2, produce interference. The thickness of air film at the point of contact of the lens and the plate is 0. Here there is no air film between these two contacts, and it appears dark. Here the center one is dark spot. When observed by the reflected light, the thickness of the film increases as we move away from the center like this. Thickness of the air film goes on increasing from the center. Let us see the expression for diameters of dark and bright rings. Here, let T be the thickness of air film, where mu is the refractive index of air and R the angle of refraction, shown in the figure 2. For the reflected rays 1 and 2, the path difference should be delta equals 2 mu t cos r. Here this path difference already derived. It is already explained in the previous videos in thin film interference. The second ray gets reflected from the optically denser medium, and hence it introduces a path difference of lambda by 2. Here the path difference should be lambda by 2 or phase difference 180 degree. Therefore, true path difference becomes 2 mu t cos r minus lambda by 2. This is additional path difference. Therefore, if the angle of refraction r is equal to 0, then cos r becomes 1. This is for normal incidence. Then the path difference is 2 mu t minus lambda by 2. Let it be equation 1. Let us see the conditions. First one, conditions for the bright rings. Path difference is delta equals m lambda. We know that the path difference for bright ring is m lambda. Let it be equation 2. From equations 1 and 2, we equate this one. 2 mu t minus lambda by 2 equals m lambda. Therefore, 2 mu t equals, on further simplification, it becomes m lambda plus lambda by 2 is equal to, take lambda by 2 outside, then this equation becomes 2m plus 1 into lambda by 2. This is the condition for bright ring, where m is equal to 0, 1, 2, 3 and so on. Let us see the conditions for the dark rings. We know that the path difference for a dark ring is 2m minus 1 lambda by 2. Let it be equation 4. From equation 1 and 4, equate these two equations, we get 2 mu t minus lambda by 2. This is the true path difference, is equal to the above equation 2m minus 1 into lambda by 2. On further simplification, we get 2 mu t equals 2m minus 1 into lambda by 2 plus lambda by 2. This is equal to, take lambda by 2 outside. On further simplification, here 1 get cancelled, we get m lambda. Hence, m lambda is the condition for dark ring, where m equals 0, 1, 2, 3 and so on. From the figure 4, look at this figure. Here, the geometry of the diagram, AD into dB equals CD. Here CD into DE. Here AD into dB equals CD into DE. This becomes R into R. R into R. AD means R. dB equals R. Therefore, R into R equals CD into 2R minus CD. CD into 2R minus CD. This becomes R square is equal to T into, CD means thickness of the air film, T, it becomes T, into 2R minus T. CD means T, thickness T, 2R minus T. Therefore, because CD equals thickness of the film, already told, therefore d square by 4 is equal to 2tr minus t square. Multiply t with this one, 2r minus t, we get 2tr minus t square, where r is the radius of the ring. Therefore, where d is the diameter of the ring. Therefore, r is equal to d by 2. Therefore, r square means d square by 4. Here, d square by 4 is equal to 2tr. This is because t square may be neglected. In the above equation, t square may be neglected because the thickness of the air film as we move away from the point of contact. Therefore, finally it becomes 2t equals d square by 4r. Let it be equation 6. Let us see the diameters of dark ring. From equations 5 and 6, we get mu d square by 4r equals m lambda. where mu is equal to 1. Refractive index is always equal to 1 or unity for air. Therefore, d square is equal to 4r m lambda. Cross multiply 4r with m lambda. This becomes 4r m lambda. Therefore, the diameter of the dark ring becomes d equals square root of 4r m lambda. Let it be equation 7. That is, d is proportional to square root of m, where 4r and lambda are being constant. Then the diameter of the dark ring are proportional to the square root of the natural numbers. Here it is, the diameter of the dark rings are always proportional to square root of the natural numbers. Let us see the diameters of bright rings. Here from equations 3 and 6 we get mu d square by 4r equals 2m plus 1 into lambda by 2. Here 2m plus 1 lambda by 2 is the condition for bright ring. If refractive index of air is unity, we get d square equals, here on further simplification, cross multiply 4r with the right hand side equation, we get 4r into 2m plus 1 into lambda by 2. Therefore, d is equal to square root of 2r into 2m plus 1 lambda. Let it be equation 8. Or 2r and lambda being constant, then d proportional to square root of 2m plus 1. Hence, the diameters of the dark rings are proportional to the square root of the natural odd numbers. Here, the diameters of bright rings are always directly proportional to square root of the natural odd numbers. Here in case of dark rings, it is always directly proportional to square root of the natural numbers. Let us see width of the rings. See here, now consider the dark ring. The diameter of the dark ring d equals 2 into square root of or m lambda. The diameters, the first ring diameter is d1, for second ring diameter is d2, third ring d3 and so on. For the first, second, third orders of the rings are given by d1 equals 2 into square root of lambda r, because m is equal to 1. For m equals 2, the diameter of second ring is 2 into square root of 2 lambda r. For third ring, diameter of third ring is d3 equals 2 into square root of, you can substitute value of m is equal to 3 because of third ring. Then it becomes 2 into square root of 3 lambda r and so on. Finally, the width between the first and second rings is always proportional to square root of 2 minus square root of 1. You can substitute the first and second rings, we can get like this, and further simplification it becomes 0.4. This is 0.4 is the width between the first ring and the second ring. The width between the second and third rings is always proportional to square root of 3 minus for second ring square root of 2. On simplification we get 0.3 and so on. That means the width of the rings decreases as the order of the rings increases. Here width of the rings goes on decreasing as the order of the rings increases. Here for first ring, second ring, third ring and fourth, fifth, sixth, seventh, like this, the width becomes decreases. Why Newton's rings are circular? This question is always arises in our mind. Here this is because the locus of the light passing through the lens of equal intensity depends upon the thickness of the air gap between the lens and the glass plate. Since the air film thickness is constant in the shape of the circle, Hence, the Newton's rings formed are circular in shape and not in square or any other shapes. That's all. Now, we can find out the wavelength of monochromatic light. See here, let us consider any two bright rings, second one or third one, or first one, second one, or fourth or fifth, like this, corresponding to, let's suppose, mth and nth orders, if m is greater than n. In this way, for the mth bright ring, the diameter is dm is given by, here m is subscript, that means rings order, bright ring order, that is given by t square m by 4r. This is equal to 2m plus 1 into lambda by 2. Let it be equation 1. This equation already derived. It is shown in the previous slides. If refractive index for air is equal to 1. In the same way, for nth bright ring, the diameter is given by, that is dn, d square n by 4r is equal to 2n plus 1 into lambda by 2. This is nth bright ring. This is for mth bright ring. Subtracting the equation 2 from equation 1, we have d square m minus d square n upon 4r. Here 4r is the common factor. Here, therefore, in the numerator, it becomes d square m minus d square n. This is equal to the RHS equations. On further simplification, we get m minus n into lambda. The wavelength of monochromatic light is given by lambda equals, here cross multiply m minus n, then we get lambda equals d square m minus d square n upon 4r into m minus n, where r is the radius of curvature of given plano-convex lens. Here d square m means this is the diameter of mth bright ring. This one d square n is the diameter of nth bright ring. Here the difference of bright rings m minus n. Here for m, if it is 10th ring, for n if it is 9th ring, the difference of these two is 10 minus 9, it becomes 1. This is the expression for wavelength of monochromatic light. Now we shall discuss about the determination of refractive index of a given liquid. A liquid of refractive index mu is introduced between the lens and the glass plate. Due to interference, rings are formed. Now the true part difference is 2 mu t cos r minus lambda by 2. If r is equal to 0 for normal incidence, then cos r becomes 1. Therefore, the part difference should be 2 mu t minus lambda by 2. Let it be equation 1. The condition for the bright ring is delta equals m lambda. This is the part difference condition. Let it be equation 2. From these two equations, we get 2 mu t minus lambda by 2 equals m lambda. Equate these two equations, we get equation 2. Therefore, 2 mu t equals 2m plus 1 into lambda by 2. On further simplification, you know that the equation 2t equals d square by 4r. It is already derived in the previous slide. Therefore, it becomes mu d square by 4r equals 2m plus 1 into lambda by 2. Let d square a and d square b be the diameters for the 8th and bth rings respectively, if a is greater than b. In the same way, m is greater than n respectively, formed in the liquid. Then, for liquid, mu d square a upon 4r equals 2a plus 1 into lambda by 2. Here m is replaced by a. Let it be equation 3. In the same way, for bth ring, mu d square b by 4r equals 2b plus 1 into lambda by 2. Let it be equation 4. subtract equation 4 from equation 3, we get mu into d square a minus d square b upon 4r into a minus b. This is equal to a minus b into lambda. Here this equation is obtained on subtracting equation 4 from equation 3. We get this equation. On further simplification, the wavelength of light lambda equals mu into d square a minus d square b upon 4r into a minus b. Let it be equation 5. This is for liquid. For air, mu is equal to 1. Refractive index is 1. Here in the above equation, mu is the refractive index of given liquid. Here in this case, for air, refractive index is 1. Then this equation becomes lambda equals d square m minus d square n by 4r into m minus n. Let it be equation 6 for air. From equations 5 and 6, for number of bright rings a minus b equals m minus n, then we get mu into, equate these two equations, mu into d square a minus d square b upon 4r into a minus b. Here is equal to mu into d square m minus d square n by 4r into m minus n. Here the wavelength should be common here. Hence we can equate equation 5 and 6. These two equations are equal here. On further simplification, the refractive index becomes, here 4r get cancelled. Here a minus b is equal to m minus n. Hence it is get cancelled. Therefore refractive index mu is equal to d square m minus d square n upon d square a upon d square a minus d square b. This is the refractive index of liquid, equation for refractive index of given liquid. Let us see the problems. First problem. In Newton's rings experiment, the diameter of 15th ring was found to be 0.590 centimeter and that of 5th ring was 0.336 centimeter. If the radius of plano-convex lens is 100 centimeter, compute the wavelength of light used. Here diameter of 15th ring is, that is dm, 0.59 centimeter. This is diameter of 5th ring. This one is radius of curvature of plano-convex lens. We can calculate the wavelength of light using this formula. By substituting these all daughters in this formula, we get, on further simplification, 5880 angstrom unit. That means the wavelength of monochromatic light should be 5880 into 10 to the power of minus 10 meter. Let us see the second problem. Given the diameters of two successive bright rings in Newton's rings experiment using wavelength 5890 and 10 raised to minus 10 meter as 0.02 meter and 0.0202 meter. Calculate the radius of curvature of the plano-convex lens. Here for this one, here data is given here. dm, diameter of mth ring is 0.022 meter, diameter of nth ring is 0.02 meter. Lambda is given here. M minus n, the difference of these two is 1. By using the formula lambda equals d square m minus d square n by 4r into m minus n, by substituting all these datas in this formula, we can get r is equal to 3.41 meter. Thank you one and all.